Yeah. So our next talk will be given by Natalia Miraserna, and it will be deep learning for effectively training a deep neural network for computer vision. So Natalia Miraserna is engineer in artificial vision, and with a special emphasis in imaging technologies and artificial visual software in a wide spectral range. She graduated in imaging and sound telecommunication engineering by the University of Alicante and obtained a master in artificial vision by the King Juan Carlos University. And now she is application engineer in imaging at Álava Ingenieros, where she is in charge of project developing based on advanced computational algorithms for image processing, communication databases, among others. So, Natalia, I'll give you the role.
Thank you very much.
Thank you very much for being here. So I think that now you can show us your presentation.
Okay, thank you. So, wait. Okay, hi again. I'm Natalia Mira, and I'm going to talk about the effectively training of a deep neural network for computer vision. Um, my presentation will be focused on the know-how of the user experience about the different cases that we have and how to apply the deep learning of some projects that we have to focus. So this presentation will be differentiate about. I'm going to do a little review of the deep learning. Then I'm going to talk more about the training data. That is the most important part of the presentation. And finally, I'm going to show some examples to interpret the results that we have of them. So, first to talk about the deep learning, we have to go to the beginning and talk about a little bit of artificial intelligence. It began of the 50s with the computers, and it was like a dream. But about these three, about the artificial intelligence, machine learning, and deep learning, what we have to know is which difference are about them. And this is a paradigm shift. The features that were used before were very basic. First, there were everything about the part of the artificial intelligence was based about a very easy features, and it was based about what we saw, what the human was directly separating, for example, into just two classes. Then, with the machine learning, the base that used it was for many features, with a second step that was using a statistical algorithm of the studying which feature work best separating classes, creating them by manually by human. The final, before the deep learning, there were more classificators that that what we do inside them it was to level the numbers. But the deep learning, instead of creating features manually that do the others before, is a handmade architecture that are created that statistically calculate which feature or mix of feature works best. So the branches of the machine learning are we can differentiate three. One is the supervised one that and the image classification is what is be using. The image classification what do is to use the labeling. What do is label every image to discriminate, but this part is very tedious because we need every label for every image. We always have to know of which class is owned. By the other hand, we have the unsupervised that and the reinforcement that don't need labels, and the unsupervised is based on clusterings and reinforcement of test and error. That is very similar of how human works, how the human learning works. It's true that the image classification is based off the supervised machine learning, but now, now with researchers is trying and is betting to use unsupervised and reinforcement, like for example the automate cars. So I'm not going to stand in this part that, as you know, is the brain of the CNN. The convolutional neural network is very large networks of multi-layer steps that are bases of a scaling and convolution on parallel by GPUs. The GPUs is the tool of the of choice training that could be the difference between hours or months of training. So, talking about the important part of the presentation, we are going to talk about the training. What this is a science, but that is true that this is an art because we need to know always which setting what that we have to use. First, what we have to do is to focus the problem that we want to solve, what we want to classify, or what we want to find. We need always to do a discrimination of what we need to have. Then the most vital aspect, as you see in the slide, is prepare the data, is to get all the images and know which features we know about them. Then in the next one, I'm going to extend about this part. And the next one is select the network architecture, if it's applicable or not. Now, there are a lot of architectures that have been done, that are created, and we have the choice the most times to do a choice of which network we want to use. For example, there are general networks just for classify, and other ones are for segmentation that is used to matching, for example, in the medical applications, and finally for use temporal data. Here in computer vision, an example of trait of this temporal data could be a tracking. We can predict what will be, for example, an object be in the next frame inside a sequence. Then what we have to do is to set the hyperparameters. For example, select the number of layers, the number of filters of every layer, and for final to avoid the many of the pitfalls. Continuing about the most vital aspect that I told in the slide before, we need always a minimum number of images of each class that is required. The more images that contain more information of every class will be always better to train. Then what we need to have through is different ways of representing every image that we have. We need to what we need is to have different images and different ways to see that image. For example, different rotation, different scaling, different aspect ratio, intensity, or color. Then, about the supervising model of the machine learning, all the images must be labeled or pre-categorized. There are already companies that are only be dedicated to labeling. And finally, it's super important to give information about the difference between every class. Once we have all the images that we want to classify, what we have to do is split them of training images and testing images. Here we have to be to train more than equal or more than the 70% of that data, that images, to train the network, and 30 or less to test the network effectiveness. This value is not set, but you must have for tests for your algorithm a minimum to generalize. Then this is important too, that well, for example, we get the 80% of data for chain, but we have to have a very good distribution of every class. And as you know, more training data, more accuracy. Saying about accuracy, the key of the training results are the accuracy, benchmark, and confusion matrix. The accuracy is often refused on recall because that one is applied and how goes it down. The benchmark is usually what we observe when we do the training. Here you can see the number of milliseconds of the minimum and maximum, uh, and this is very important to know how it's doing the training, and then how will be done the test to know if to use it or not in online projects. And finally, in the confusion matrix, we study how many errors we have in comparison of the positive one, the positive ones are the true positives and the false positives. Sorry. So here we have an example of two classes, and what will be ideal is when we have the high levels that difference at all, which is one class and another. But normal is not the normal way because we always have a part that converts and is the most level that we have to be trained. The quality results for manual inspection and network is retraining. To do and there is where the confusion matrix comes in. To do better the network, this data is the one that has to be retraining. So here we have an example of a classification. There is 5 classes, and then we have the score of this image, and say that is the 90 but 69% of the score. The score indicates how likely image belongs to a class, and of course, statistically, it's never is possible to get the same percent, the 100%. So here we have a MEAL case study. MEAL is Matrix Imaging Library. This is a tool that we use for our projects, and this is an example of sorting the shell and muscle base of shell fragments. This is used by X-ray images. As told in the presentation before, can use every kind of images that could be of gray intensity, color, thermography, and this one is based off the X-rays. And here what we do is to classify between okay or not okay, what is the muscles or the shell fragments. And the sorry. This project, the training preparation took for 4 hours, and what we did is to take all the images and multiply for 6 the number of images that we had. Why? Because we have just one image. What we do is to change always the rotation, the scale, the ratio aspect, the intensity. We need always to have different scenarios to train. So 2,000 images goes to 12,000. So the conclusion of this project was using an NVIDIA GeForce GTX with that card, with the 30% of images used exclusively for validation. We get the 99% report of the system integration of accuracy. So this is all for me. If you have any questions, here you have my contact. If you have any question about that, and I get the LinkedIn, the LinkedIn links. If you have any question of do you want more information, this is for me, Group Álava, and for Matrix Imaging Trip. I don't know if you have any question.
Sorry, Natalia, I thought you could hear me. So thank
No,
you very
sorry.
much for the talk. I think it was very interesting to have like this broad overview at the beginning, so people that are not familiar with the topic of deep learning and machine learning, they could understand a bit more what is it about. So I really appreciate that part. I saw that you are using a NVIDIA GTX, I assume you're using that one because you have a relatively reduced data set. So I assume that if a company wants to invest some money and do some very big training of algorithms, I guess that they should invest. What do you think? So they should invest a lot of money in terms of hardware and data storage
Um,
and all this.
as I told in the beginning, this is very important to have a very good one GPU, and I don't know how much data you have to train. Always you need more potential GPU. So yes, I think it depends always about the project or how many images do you have. I know just about the which kind of images because you could have 12,000 as the example that I showed, but maybe that sorry maybe that images are shorter than another ones that could be of HD resolution. So it depends. It depends always of the data that you want to train, and it depends of the time do you want for your project. If it's an online project, always you need a very potential GPU.
Mm-hmm. I see. Yeah, it makes sense. It totally makes sense.
Yeah.
Ismael Sanchez has a question, which is, what library did you use for deep learning? So do you program your networks on your own, or you use any other?
No, now what we are using is Matrix Imaging Library that has its own model of classification.
Okay, but it's an open source library, or?
No, it's a commercial library.
Okay.
Yeah.
And the reason for choosing this library against other open source libraries, is there any particular reason you think it's more suited for your applications?
Now we're using Matrix because for them it's a robust it's a robust model that they have, and always for me it's better to use this kind of libraries because always you have support to help you always, and you know that will be always having the last trends, and will be always developing more developing oh sorry um, more facilities to do
Hmm.
these kinds of algorithms.
Okay. I also have one more question from Ismail that says, how can you make sure that the neural network has the right structure? So how do you choose the structure you use on the neural networks? How do you find out what is the optimal number of hidden layers? Um,
Sorry, could you ask again because in the beginning of the question
okay,
I didn't
okay.
hear any sentence. Sorry.
So Ismail Sanchez has a second question, which is, how are you sure that the neural network that you're training has the appropriate structure? So how do you choose the architecture of your neural network, the number of parameters, of hidden layers, of convolutional layers, etc.?
Normally is knowing is getting the solution and then modifying the parameters. Once you have the first one, more or less you can know which parameters do you use. Uh, Now there are a lot of networks that are done, and what you do is to use like a default one, and then what you do is to modify more or less every parameter, and retraining to know how are you going to go to a solution approximately.
Okay, so you don't use.
Because with a default one, you get like the 90% of accuracy. Then what you do with that general one is to change that parameters with more layers, for example, and more images of retraining, because when you have the result, you see where are the false positives, for example, and then you know which images have to use more or not to create a better network.
Okay. So you do some sort of optimization in all this process, but you do it by hand. There is not an automated process that checks how many layers you use and adapts them according to the resolution and the physics.
Normally, it's getting the solution and then retraining.
Okay. Okay.
Yeah.
Okay. Very interesting. So thank you very much, Natalia, again for your talk.
Same for you.
I think it's time to move to the next one.
Okay, thank you.
Thank you.